Okay, so today we will go to the next point. So that is TreeSet, Java TreeSet. So it's important for the interview point of view. It is important. So in our last class, I had told set feature age duplicates are not allowed. Insertion order is not present. But we saw in case of linked has said insertion order was preserving. So next implementation class of set interface is TreeSet. So first point, it is an implementation class of set interface. Underlying data structure of TreeSet is balanced tree. That means when I will declare a TreeSet object internally, a data structure will create. Tree is a data structure. Particularly, balanced tree will create internally where the data item will assign in the form of a balanced tree. So there is no need to know the detail of balanced tree. Tree means there is a root node and there is a left soft tree or left node or right soft tree. This is a tree. Tree is a data structure. Tree is a such a data structure consisting of nodes, each node containing some data item. Okay, so balanced tree means just little bit information that I am giving. Balanced tree means what? Each node degree, every node have a degree if either 0 or 1 or minus 1. Then that tree we can say it is a balanced tree. So how I will find the degree of a node? Suppose this node, this is the root node. Okay. So this node degree, how I will find? Height of left soft tree. This is left soft tree and this is right soft tree. So height of left soft tree means how many number of branches or nodes? 1, 2. 1, 2. This is the height of left soft tree minus height of right soft tree. There is in right there is one node, so height is 1. Height of left soft tree that is 2 minus 1. This is 1. Similarly, what is the degree of this node? The height of left soft tree, the height of right soft tree. So there is no left soft tree for this node and there is no node in right hand side. So degree is what? Height of left soft tree, there is no node. This is 0 minus 0, that is 0. Similarly, the degree of this node 1 minus 0, that is 1. 0 minus 0 for this node. If I will find the degree of this node, this height, there is no node, so 0 minus 0, that is 0. So degree of each node, if it will be 0 or 1 or minus 1, then that tree is known as balanced tree. And here data item will assign. Okay, suppose 50. Then if I will suppose some data item I will assign. First data item it will consider as root node. Suppose second data item I will assign 70. So 70 will compare with 50. If it is greater than, it will go to the right hand, right soft tree. If it will be less than in compare with the root node, then it will go to left software in this way. But it is the internal mechanism. Little bit knowledge if you want to know, then it will be better. So there is no need to go through in detail, but just little bit information that you should know. It will be better for us. Okay, so when I will declare a tree set object, when I will declare a tree set object internally, a balanced tree is creating for the assigning data item. So this point I have written. So that's why underlying data structure for a tree set is balanced tree. That means when we create a tree set object internally, a balanced tree will create for containing data items. Duplicates are not allowed since it is the implementation of set interface. So definitely that set features it is allowed. Duplicates are not allowed. Insertion order is not preserved, but all data items are inserted according to some sorting order. According to some sorting order. That means when I will declare a TreeSet object, then by invoking add method, I will insert some data items. So when I will get the output, data items will come in the form of a sorting order, arranging data items either in ascending order or descending order. Okay, sorting default is ascending order. If I will go for a descending order, then we have to customize. We will see. Okay, so then another point is coming to the picture. If TreeSet is a such collection, TreeSet is a such collection which is meant for sorting. So definitely all the data items are homogeneous. If the data items are not homogeneous, means similar, then sorting concept will not implement. Suppose we have 200, then we have 100. So 200 is comparing with 100. So 200 is greater than 100 or less than 100 or equals to 100. So accordingly, the control will place 200 put in perfect place. Suppose first data item 200, it is integer data item. Next data item is Java, it is a string value. How it will compare? So since this is one such collection, this is one of the interview question. Every collection that we know that it is allowing what for containing multiple types of data items, but it is a such collection since it is meant for sorting. So data items must be homogeneous. Okay, just to see next point I have written heterogeneous data items are not allowed. That means multiple types of data items are not allowed. If we are trying to insert heterogeneous data items, then we will get a runtime exception that is known as which exception? Class cast exception. If I will take multiple types of data items, definitely it will return an exception, and that is class cast exception. Then null insertion is allowed. Null insertion is possible, but the condition is but only once. If we will insert null in the middle, then we will get a null pointer exception. This is one of the important points. Null insertion is possible. You think you have a tree set object, and suppose if you want to insert a null value, first first data item you will consider as null. Then after that there is no data item. Then that will be valid. But if again you will insert a new data item, suppose 200. So how 200 will compare with null? Suppose you have some integer data items in middle. Suppose you inserted a null, then also it will give a null pointer exception. The concept is saying, so if I want to insert a null value, if I want to insert a null value, then only once I will take a traceset object. Only once first data item if I will insert null, Then apart that I will insert, I will know but not insert any data item, then that will be valid, otherwise null pointer exception will arise. So this is overall some points about TreeSet. It is important. Then we will go for constructors. So first is what a tree set. So simply this is first constructor. So when I will declare a tree set object, so the constructor will execute. So what it is representing, what it is meant for. So creating an empty tree set object where data items are inserted according to default natural sorting order, that is ascending order. Currently I was saying, so when I will declare a tree set object simply, then after that I will add some data items. Okay, so when I will see the output, so data items will come in the form of ascending order. You remember, default natural sorting order is ascending order. If I want to see data items will come to the picture in the form of descending order, then we will go to second constructor. Preset. Second constructor is within bracket comparator C. So comparator is an interface. In later on I will discuss the very important interview question. What is comparator? So there is a popular interview question, comparable versus comparator, that we will discuss. So what is the purpose of this constructor? Creates an empty tree set object where data items are inserted according to customized sorting order. If I want to see the output will come in the form of a descending order, that is what customized. Okay, so if that will be my requirement, so what I will do, so I will represent this constructor. Then this part already what we have known. For any collection object we can create an equivalent preset object. Okay, so now I will go to some example. Import java.util.star package. Let class TreeSet example of public static. So void main string args. Okay, so now I will declare a TreeSet object. TreeSet t. Suppose since it is generic, suppose within angle brackets, it will be better practice. Angle bracket, suppose I will specify integer. That means I will insert integer data items equals to new preset. This so t dot add method, or let's suppose 300. T dot add method, let's 200. T dot add method, let 500. T dot add method, let 100. Okay, so if I will add t dot add null, if I will add t dot add multiple types of data items, let Java system dot out dot println, so t. So now just I am giving this two line, I am giving comment. This now I will save reset example dot Java. Now I will do all files, then I will save. I will go to comment prompt. So now I will go to A drive, go to Java programs folder, Java C, TreeSet example.java. Okay, so now I will hit run Java space class name TreeSet example. So you see, so 100, 200, 300, 500. But first I had inserted 300, then 200, then 500, then 100. But when I got the output data items coming in the form of ascending order, basically this is called as what? Default natural sorting order. This is called as what? Default natural sorting order. So there is an internal mechanism how the control is comparing and internally which method control is invoking. I am coming to that point. So first of all, you see, so we got data items in the form of sorting order, and that is default is ascending data items coming in the form of ascending order. Now, suppose I will insert a null value, a dot add within a bracket null, if I will write. So we have written, I have told what in middle, if I will insert a null value, so null pointer exception will arise. You see, while I will save Java C preset example dot Java Java space class name preset example. So you see exception raised. Exception in thread main java dot lang dot null pointer exception. So we saw when inserting null values or when inserting null, what we are getting? We are getting null pointer exception. Suppose if I want to insert what? Another types of data, Java. It is a string value. So now I will save. Now I will run Java C reset example.java. Okay, so why it is coming this in this way? Because we have to here mention string because it is generic. So whatever you have specified accordingly, you have to insert the data item. Suppose I will write string. Now I will compile Java C reset example dot Java. Okay, so again wrong number of types arguments. Trace set integer comma string equals to new trace set integer comma string. Okay, let it. So I will not. I'm not specifying the generic. The since it is generic. So suppose it is optional. Suppose I will not specify. I will show you Java C reset example.java, then Java space class name reset example. You see. So class cast exception. My point is, so when another type of data item I will insert, so exception in thread main java.lang class cast exception. So we are getting a runtime exception, that is class cast exception, it is arising. So what we are observing? So we observed. So in TreeSet context, when we will insert data items, so always I will insert what? Homogeneous types of data items because TreeSet meant for what? TreeSet meant for sorting. So data items are coming in the form of sorting order and what default sorting order is ascending order. Okay, so now, so I will save Java C TreeSet example dot Java space TreeSet example. Okay, so overall we got the clarity. Okay, so then all acceptance already what I explained. So this is another example, but I think in JDK 7, 8 it was not accepting, but now it is JDK 20. Currently Java 20 version. Now in current version it is supporting. So in this next example here you see some a string value that we are inserting, but a string value. So which type of class I have taken? String buffer. So already we have known string, string buffer, string builder, and a string tokenizer. There are four built-in classes that we can use for representing strings. So here string values. So we have taken so by string buffer class. Odisha, Mumbai, Delhi. Then preset object I have taken, then system.out.println t. So when you will see the output Delhi, Mumbai, Odisha. So string value, first D, then M, then O. So first character. So control will search these three values, Odisha, Mumbai, Delhi. So default natural sorting order is ascending, so we will get the output. Then question is how it is what evaluating. That means how the control is providing the output in the form of sorting order. Definitely, suppose if I will consider this example 300 first data item, then second data item 200. So 300 is comparing with 200. Then who is comparing? 200 is coming first position, then 300 is going to second position. So internally, we are getting outputs directly. Okay, data items are coming in the form of sorting order. But internally, some process is going on, and we will see one method. That method name is compare to method. That method name is compare to method that is invoking. So we will see the next point that is very important, that compare to method is coming from comparable interface. So the next point that we will know what is comparable interface. So what is the internal mechanism in which way the control is comparing each data item, and as a result it is forming data items are in the form of ascending order. So this is very important interview question, comparable interface. Okay, comparable interface. So comparable, you see comparable is an interface, and in comparable interface there is a method, built-in method, compare to method. There is a built-in method, compare to method. So this compare to method internally it is invoking. And what is the syntax of compare to method and what is general form of compare to method? It is the only one method coming from comparable interface, comparable. So it is returning. So first of all, you see this is the general form. First data item actually in collection framework context, data items what considering in the form of object. Suppose 100 in the data item, but the control will understand it is integer object data. Okay, so that's why I have specified it outside object 1 dot compare to object 2, object 1 dot compare to object 2. So first data item dot compare to second data item. In this way we can understand. So it is returning, it is returning three values: negative value, positive value, and zero. So negative it is returning when the first data item is coming before second data item. Okay. If first data item is coming before second data item, you see an example also I have taken. A is a string value dot compare to, within bracket I have written Z. So first A will come before Z. A will come before Z. So it is returning a negative value. Negative value means any negative value. Suppose in output already I have what executed. So suppose minus 20, 25 came. Any negative value. Similarly, returns positive if the first data item coming after second data item. Z compare to Z is a string value because I have identified within a string double quotes. Z dot compare to, within bracket I specified B. So Z is coming after B. Z is coming after B. So it will return positive value. Okay. So first data item, this is the syntax. This is the general form of compare to method. If it is a compare to method is a such built-in method, it is returning what three values: negative value, positive value, and zero. If first data item is coming before second data item, then it is returning negative. If the first data item is coming after second data item, then it is returning positive. If first data item is equal to the second data item, then it is returning zero. And if first data item, what this is called, but if I will compare with null, then null pointer exception we will get, but actually returning three value: negative, positive, zero, negative, positive, zero. We will see. So import java.util.tar package class comparator, comparator demo public static void main string args. Suppose one output statement I will write directly system.out.println. So what I told a dot compare to method so z. Now I will write another statement system.out.println just for what providing clarity. But you remember it is the such built-in method internally control is using, it is invoking each two data item is comparing by this method println. So if I will write z dot compare to method and this is a, so I will write one output statement system dot out dot println, let a dot compare to method this, this. Now I will save comparator demo.java. Now I will do all files. I will save. I will go to command prompt java c comparator demo.java java space comparator. You see, first output statement A dot compare to Z. First data item is coming before second data item. That's why it is returning a negative value. In second output statement, a first data item is coming after second data item. So it is returning a positive value. Third output statement is representing first data item is equals to second data item. It is returning a 0. Okay, so this is compare to method purpose. If I will, yes, if I will compare with null, system.out.println, right, a dot compare to method within bracket, I will write null. Then Java C space comparator demo.java, then Java space class name comparator demo. So you see, when I am comparing with null pointer exception will arise. So when I will comparing with null, so null pointer java dot lang dot null pointer exception will arise. Okay, so I hope you got the clarity. So this is all about reset. Then in my next class we will cover comparator interface. It is this tree set. It is what we discussed what default natural sorting order. Okay, so default natural provide. So what we studied what. So internally the class is implementing comparable interface and what a built-in method is invoking for comparing data items, that is compare to method. Okay, so if we are depending on the default, you see, I've written in note point. If we are depending on the default natural sorting order, internally the compare is calling compare to method and it will inserting data items to the tree set. Hence, the object should be comparable. So comparable means what? Comparable is an interface. Whatever you are taking class, that class should implement comparable interface and internally compare to method is invoking for comparing data items. Okay. So I hope you got the clarity.